right, so we're going to talk now about section 5-4, medians and altitudes. And this does bring us to our last 2 points of concurrency for triangles. So hopefully that's helpful to some of you. In-person classes, we will do some practice and some foldables to further incorporate the points of concurrency. And online classes, I will do my best to get those uploaded to you as well. All right, so for the 5-4 reteaching, let me go ahead and change it up here. Let's go with some purple. Completed notes. All right, so here we have a median of a triangle. It's a segment that runs from one vertex of the triangle to the midpoint of the opposite side. And note that it doesn't necessarily meet at a perpendicular, okay? That would make it a perpendicular bisector. Medians and perpendicular bisectors, not always the same thing. A median goes from corner to midpoint, okay, or vertex to midpoint. The point of concurrency of the medians is called the centroid, and the centroid has a really neat connection to the lengths of the medians that it creates, okay? So we'll talk about that in a minute, and that's how we're going to solve a lot of our problems here, I do believe. So the medians of triangle ABC are AM, which goes from vertex A to the midpoint of CB, CX, which goes from vertex C to X, which is the midpoint of AB, and BL, which goes from vertex B to L, the midpoint of AC. The centroid is the point where all of those meet, which in here is point D. Okay, so just an intro to what is a median, what is a centroid. The next two, or the last two vocabulary terms for points of concurrency is altitude and orthocenter. An altitude of a triangle is a segment that runs from one vertex perpendicular to the line that contains the opposite side. And again, an altitude can be a perpendicular bisector if it bisects the side it hits. But the bare bones of an altitude is that it goes from vertex perpendicular to the side across from it. Vertex perpendicular to the side across from it, and RU vertex perpendicular to the side across from it. All three of the altitudes meet at a point called the orthocenter. Orthocenter is the point of concurrency for the altitudes. By the way, I've said point of concurrency for a couple lessons now, and I hope that you have ascertained what that means. But a point of concurrency is a common point where three segments meet. So the point of concurrency for the altitudes is the common point where the three altitudes meet each other. An altitude may be inside or outside the triangle or a side of the triangle. The altitudes of triangle QRS we mentioned here were QT, which goes from vertex Q, perpendicular to SR, which meets at point T. RU, which starts at vertex R and meets QS at point U at a perpendicular or right angle. And SN, which starts at vertex S and meets side QR at point N at a right angle or perpendicular, okay? So the vertex, or the orthocenter is point V. Sorry, I saw that V and said vertex. That's not true. The orthocenter is point B. The orthocenter is where the three altitudes meet. All right, so we're going to use what we know about medians and altitudes from these notes and determine whether what we're looking at here is a median, an altitude, or neither. Now, we may want to make some notes here that a median goes from vertex to midpoint. So vertex to midpoint. Okay. And an altitude, I'll go ahead and underline that so that we can connect these terms together. And then let me switch colors to do the same kind of thing for altitude. An altitude goes from vertex to a right angle. Vertex to right angle. Okay, so altitude is going to go from vertex to right angle. Okay? All right. So let's look and see what we have here. On number 1, we see we have a segment AB coming from A, and it meets at a right angle. Meets at a right angle. So vertex to right angle here is going to be an altitude. Altitude. Okay? So noticing here that on number 2, we have a segment AB coming from a vertex to a midpoint. We know B is the midpoint because it cuts TZ into two equal pieces, which we know by those little slashes. So we know the segment AB here on number 2 is a median. Okay. All right. For 3 and 4. For 3, again, we have A coming at a right angle. So vertex to right angle is an altitude. We're going to go back to red to make sure that we are consistent with our colors here. So here we have an altitude. Okay, and for number 4, we have A coming down to a point B on FE. It's not at a right angle, but it does not show those two segments equal. So we're going to say neither on this one. There's neither a median nor an altitude, but hopefully you can see what it actually is. Okay, so this one is neither, but you can see that it does, AB does cut angle FAE in half, this two equal segments, so it is an angle bisector, but it is an angle bisector. Okay, so make sure that you have those notes. Number 5, I want you to name the centroid. The centroid, you can look back up at your notes here. The centroid is where the 3 medians meet. Medians go from vertex to midpoint. Vertex to midpoint. So SB is one of the medians. Let's go ahead and list the medians. Medians, SB. The next one is U, and did it say what point it goes to? I guess we should name that point, shouldn't we? So we have something to call it. Oh, B is that point right there. We can't do that either. Well, okay. All right, so I'll just trace over them. How about that? This is a median that goes from S down to that midpoint, okay? And then the median that goes from U to the midpoint of ST. And then we have, well, we don't have another median drawn here, but we can see that the two that we have drawn meet at point Z. So the centroid is at point Z. The centroid is Z, okay? So the orthocenter is again where the altitudes meet, and altitudes go from vertex to right angle. So let's trace over the altitudes here. Vertex to right angle, vertex to right angle. Notice that the segment coming from Q is not an altitude, it is a median. So vertex to right angle. PT is an altitude, okay? But QS, or this one coming from Q is not an altitude, okay? But the one coming from R to a right angle to the side opposite it, so P here is going to be the orthocenter. P here is going to be the orthocenter. So this is going to take some going back to your notes. Orthocenters where the altitudes meet. Altitudes go from vertex to right angle. And you can see that QP it actually is an altitude. It goes from vertex to right angle there. So we can actually trace over that. Also, vertex down to right angle. So point P is definitely the orthocenter of that. Use your notes on this, please, please, please. Okay? All right. So the problems on the next page of 5-4 tells you about that really neat relationship that a centroid creates with the segments of the medians. The medians of a triangle intersect at a point 2/3 of the distance from a vertex to the opposite side. This is the concurrency of medians theorem. And again, I don't care that you know what the theorem's called. I just want you to understand what's happening here. So this says that CJ and AH are medians of ABC, and point F is the centroid. So CJ and AH are medians. Notice that CJ goes from point C to the midpoint of AB, which is J, and AH goes from vertex A to the midpoint of CB, which is H, okay? And point F is the centroid. So basically you have a short piece and a long piece. You have a short piece and a long piece of a median, okay? The short piece is 2/3 of the entire thing. It's 2/3 of the entire thing, and then FJ, of course, is 1/3 of the entire thing. So if we can think of this in terms of 3 pieces, CF is 2 of those pieces, and FJ is the other piece, okay? So this says that point F is the centroid of triangle ABC. If CF is 30, so this is 30, then what is CJ, okay? Well, if CF is 30, and that is 2 of the pieces, 30 is 2 of what? Well, 30 is 2 of the 15s, okay? Which means that FJ is the other 15. Okay. So then CJ in its entirety is 45. And they worked this, well, sort of algebraically down here. They're using the fact that CF is 2/3 of CJ, and since we know that CF is 30, then they are dividing both sides by 2/3. Dividing by a fraction is the same as multiplying by its reciprocal, so they're multiplying both sides by 3/2. 3/2 times 30 is 45. So, this is going to make you want to punch something into a calculator, and I would much rather you understand what's happening here. This is a 2/3 piece and a 1/3 piece. This is 2 of the parts. 2 of the parts. If 30 is 2 of the parts, then the parts are 15, because 2 15s is 30. We'll talk more about this in class, but hopefully these practice problems can help us firm up this understanding as well. Because I'm not going to take you through a situation or a process that is going to necessitate you just punching stuff into a calculator, because you're not learning anything then. All right. So 7 through 12 here, and I do believe when I made these foldables for class, I made multiple versions of this figure because you're going to need to be labeling them over and over again. All right, so 7 says if XR is 24. Well, we can see the entire thing here is 24. The entire thing is 24. So if we split that into 3 pieces, XZ is 2 of those pieces, and ZR is the other one, because XZ is the long piece, ZR is the short piece, okay? So let's make some notes here. Split the centroid into 3 pieces. The long part is 2 of those pieces. The short part is 1 of those pieces. Okay? So if I split the centroid into 3 pieces, well, if I split 24 into 3 pieces, then each piece is 8. Each piece is 8. Okay? Or 1 piece is 8. 1 piece is 8. Okay? So 1 piece is 8. So if I'm looking for XZ, I can see that XZ is the longer portion. The longer part is 2 of those pieces. So then XZ is going to be 16. Okay. And ZR is the shorter of the piece. The short piece is 1 of the pieces. One of the pieces is 8. Okay, so XZ is 16. And ZR is 8. And you can see that 16 plus 8 does in fact equal 24, and XR, this whole thing, is 24. Now each one of these problems probably isn't going to start from the whole thing. So we're going to need to think of, really wrap our minds around the concept of this, okay? And I am going to change colors with each of these problems, because I just bet that my notes are going to run into each other. Okay, so looking at 8, XZ. XZ is the long piece. If the long piece is 44, if the long piece is 44, the long piece is 2 of the pieces. So 44 is 2 22s, okay? So 1 piece is 22. All right, so XZ is 44. I can see that ZR is the short piece. So the short piece is 1 of those pieces, okay? Short piece is 1 of those pieces, so ZR is 22. Okay? And XR is the entire thing. So XR is XZ plus ZR. XZ plus ZR, 44 plus 22 is 66. So you're going to have to really be careful and know exactly what they're asking you here. Okay? All right, so looking at 9, this tells you that VZ, which is the long piece, the long part, okay? VZ, which is the long part, is 14. Go to blue. 14. The long part is 14. So 1 piece then is 7. Because the long part is 2 of the pieces. Okay? So if 1 piece is 7, that means that ZP is 7. Okay? That's a 7. All right, so then VP is VZ plus ZP. VZ plus ZP is 14 plus 7, which is 21. Okay. How about some purple? Okay. So looking at number 10, this says if VP is 51, VP is the whole thing here. The whole thing here is 51, okay? So if we think of that whole thing as 3 pieces, 51 divided by 3, 51 divided by 3. 1 piece, 51 divided by 3. And this is something that I wish was not a lost art, but 51 divided by 3, you can still divide things on paper here. I know you can punch it into a calculator, but watch. 51 divided by 3, just like this. 3 goes into 5 one time. 1 times 3 is 3. And then you subtract. 5 minus 3 is 2. Bring down your 1. And 3 goes into 21. 17 times evenly. And then 7 times 3 is 21. And then you subtract and you get 0. So that tells us that 1 piece is 17. Okay? So we have VZ being the long part and ZP being the short part. The long part is 2 of the pieces, or 17 times 2, which is 34. Okay, and then ZP, which is the short part, is just one of those pieces, which is 17. And since the entire thing was 51, you can see that 34 plus 17 is in fact 51. Okay, I really hope you're listening to this and not just pulling it up and copying the notes, because the explanation is a big part of this. All right, so let's go back to green. Okay. It says if ZO is 10. Well, ZO is the short part, so that is one piece. ZO is the short part, so that's one piece is 10. Okay. ZO is 10. YZ is the longer part. The longer part is 2 pieces. The longer part is 2 pieces, so that is 20. Okay, and then YO is the entire thing, which is YZ plus ZO. YZ plus ZO is 20 plus 10, which is 30. Remember, you can always watch this over and over again, try to get a little bit more understanding. Okay, so looking at 12, this is our last one, and we start with YO. YO is the entire thing, So if you think of that in terms of 3 pieces, what are we going with now, red? Yeah, 3 pieces. If YO is 18, 18 divided by 3 pieces means that one piece is, is 6, okay? So if YO is 18, that means one piece is 6. So ZO is 6. ZO then is 6. That's our short part, which is just one of the 3 pieces. YZ is the long part, and that's 2 of the pieces. So 2 6s is 12. And you can see that YO is YZ plus ZO, and 12 plus 6 is in fact 18. So we got that one also. All right, so in exercises 13 through 16, I want you to name each segment. Okay, so this is just a naming exercise. What do we start with? Purple? Let's finish with purple. Okay. All right. So 13 wants a median in triangle DEF. A median in triangle DEF. Well, if you look back up at your notes, you can see that a median goes from vertex to midpoint. A median goes from vertex to midpoint. So vertex to midpoint, well, D is a vertex, and it came down on a midpoint here of L, so a median is DL. And I will go ahead and put the segment over it just to be correct about it. Okay, an altitude in triangle DEF, and again, if you look back at your notes, an altitude goes from vertex to right angle. Vertex to right angle. So DL is not right because it's not a right angle. I do see a right angle here. Vertex to right angle, FK works, so let's go with FK. So FK is an altitude in triangle DEF, okay? So we're going to look now for a median in triangle EHF. Triangle EHF. Triangle EHF. I hope that y'all can see that triangle EHF. We're looking for a median, and again, a median goes from vertex to midpoint. EHF, well, H is a vertex, and it comes down at the midpoint of EF, which is L. So HL then would be a median in triangle EHF. HL. Okay? I really wish they hadn't have put one figure inside the other there, but it is what it is, and we're almost finished. An altitude in triangle HEK. HEK. Remember, an altitude goes from vertex to right angle. In HEK, H is a vertex, and looks like it comes down at K, which is a right angle. So HK then is actually an altitude, even though it is a side of the triangle. HK is an altitude of triangle HEK. All right, I feel like you may need to watch this a few times to really let this sink in, but please do that. It is well worth the time to grasp these concepts. Saving. All right, I'm going to get these posted and uploaded. Sorry they're so long.